Hello everyone. Today we are going to see the editorial of LeetCode question number 189 where we have to rotate the array. So let's see the editorial of this question. So we are given with two things. First thing is we have given with array and we have given k values. So let's take one example. Suppose array given is 1, 2, 3, 4, 5 and k value is equal to 1, means that we have to rotate it by one time. So if I will rotate this, 5 will come first, right? So 5, then this will be 1, 2, 3, 4. Now suppose we have to rotate it one more time. So how we will rotate? 5 will shift here, 1 will shift here, so 5, 1, 2, 3 and 4 will come here. Suppose we have to rotate it one more time. So it will be 3, 4, 5, 1, 2. Now suppose again we have to rotate it. So we are rotating again and again, so we will come to a conclusion. So it will be 2, 3, 4, 5, 1. Let's say rotate one more time. So if you will rotate one more time, you will see that we again reached at the same place. So can I say that when we have rotated 1, 2, 3, 4, 5 times, when my k is equal to 5, which is nothing but equal to n value, n is nothing but length of array, we got original array, right? Now if we will rotate one more time, means k is equal to 6, then what we will get? We will get again 5, 1, 2, 3, 4. We are getting same thing for k is equal to 6, which we got for k is equal to 1. So from this we can conclude this, that means if k value is given anything, k value is given anything, we can do modulo n. Answer will be same, because we have seen that when k value was 6 here and k value was 1, answer was same. Same way when k value will be 11, answer will be same. The rotated array will be same. So this is our one observation where we can reduce k is equal to k modulo n. So suppose in this question only it will help us to reduce the time complexity, because suppose k value is given as 1010 power 5, we know that either we will rotate 10 power 5 times or we will rotate 0 times, it will be same. So here by this way we can save the time. Now let's move forward in this question and let's see some of the methods to solve this problem. Let's say method 1. Method 1 again will be our brute force approach. So how to solve this problem using brute force? Suppose this is the array given, k value is equal to 3. So these are the indexes. Now we know that here n value is equal to 7. So we will do k is equal to k modulo n. So we will get 3 modulo 7 is equal to 3. So what we can do is, we know that all these three elements are going to, means it's going to get reversed. So what I will do is I will keep one pointer here. Let's name this as I pointer. So what we will do is we will take another array of same length, suppose make this as temp array. What I can do is, first I will copy these three elements, so I will get 5, 6, 7. Now then I will copy from index 0 to this element. So in that way I will get 1, 2, 3, 4. So our brute force is pretty simple. We have to locate k value, we have to rotate k value, and we have to place our I value at that place. So from first we will copy from I to n minus 1, then we will copy from 0 to I minus 1. We will copy in the random array temporary array, and this temporary array will say us the reverse array. Now if we will talk about time complexity here, so time complexity for this code will be big O of n only, because we are iterating only one time. From I to n minus 1 we are iterating, then 0 to I minus 1 we are iterating. I hope you all will able to write this to for loop. And if you need to know the index of I also, you can do this mathematically, right? So if it is 3 from the last, so what it will be from the starting, you can just check by the index value. Now let's talk about the space complexity. So as we are defining our temporary array, right? So if we are defining our temporary array, so in this case also time complexity will be big O of n. So in this way, time complexity and space complexity is both big O of n. Now here main point is that, can we reduce this space complexity? Is it possible to reduce this space complexity? The answer is yes. It is possible to reduce this space complexity, but how we can reduce this space complexity? So let's talk about this. Let's take this one. Now suppose I will say you to write a function to reverse the entire array. Now just suppose I change this question now. My question is reverse the entire array. So I will say reverse the entire array. So my answer will be 7 6 5 4 3 2 1. I need a function for this. So what is the function we will write? So can I say that we will use two pointer and we can update the same array? So let's write a function public void. I am writing here void because we are going to change this same function, same array. Let's name this array as nums. Now public void reverse, it will take nums array. Now how we will write its code? We will first define n is equal to nums dot length, then we will define I value is equal to 0, and we will take j is equal to n minus 1. So we are keeping two pointers here, right? One pointer here, one pointer here, and we will keep on swapping and move our I pointer to right side and move our j pointer to the left side until unless it is not crossing each other. So I will write while I less than equal to j. So once it cross each other, we will stop there. So how we will do? We will swap it. So we will take one temp variable. Temp is equals to nums of I. Nums of I is equal to nums of j, and nums of j is equal to temp. And then what we will do? We will increment I plus plus and we will do j minus minus. So this array, this function will reverse this array. Now if I will say you here k value is equal to 3, n value is equal to 7. Again every time you know that you have to do mod with k, so k is equal to k modulo n, again it will be 3. So we have to reverse this 5 6 7, right? So what if in this reverse array I will say the reverse first k element. So if I will reverse only first k element, then what I will get? I will get 5 6 7 and 4 3 2 1. Now we reverse the first k element, right? Now what is our output will be? So can I say that we have to reverse next element also? So now next operation will be reverse n minus k elements. Except this k element, this is n minus k, so we will reverse this. So our answer will be 5 6 7 1 4, sorry, 1 2 3 4. So this is our desired answer. Now let's take one more example, then it will be more clear to you all. Let's take 1 2 3 4 5 6 and k value let's take is equal to 4. Our first operation will be reverse entire array. So if you will reverse the entire array, I will get 6 5 4 3 2 1. Then our next operation will be reverse first k element, right? So these are our first k element, so we will reverse this 3 4 5 6, and then we will reverse n minus k remaining element, right? So it will be 3 4 5 6, and this we are dividing into two parts, so it will be 1 2. So this is our answer. So in this we have to write only three things, right? So reverse the entire array, reverse first k element, and then reverse remaining n minus k element. So if I will talk about exact time complexity, first time complexity we are taking to reverse the entire array. So what is the time complexity in this? Time complexity is n by 2 because we are iterating till the half. Then we are again taking this reversing the first k element. So for that also it will be k by 2 plus n minus k by 2. So overall if you will look, it is nothing but 2n by 2 is equal to n. So time complexity is nothing but big O of n, but space complexity is reduced to 1 in this case. So space complexity is reduced to 1. In previous approach we have seen that space complexity was big O of n, that we have optimized here and we have kept big O of 1. Now to reverse this first k element, I am leaving to you all to code this, because some methods, some languages have a inbuilt function where you can directly reverse it, and for some you have to write the code. So I am leaving this to you all because I already gave you the code how to reverse the entire array. I hope you will make modification to this and you will able to solve this problem.